We're traveling to a place that feels familiar, and yet is endlessly strange. The moon hangs above us like a quiet witness, pale, patient, and almost expressionless. But if you look closely at its face, you'll notice it isn't smooth at all. It's marked by countless scars, bright splashes, dark plains, ringed basins, and ancient wounds that have never truly healed. Not because the moon is alive, but because it is still, and it keeps its history the way stone keeps a footprint. In this documentary for Sleep, we'll drift slowly across the moon's surface and listen to what silence can preserve. How the moon was born, what carved its craters, why its seas are dark and calm, and why its face still looks like a memory that never fades. Take a deep breath and let the night sky open. Long before it became a symbol, before it became a lullaby in the sky, before it became a clock for farmers and sailors, before it became a bright coin tossed into the velvet of night, the moon was simply raw material, drifting through a young solar system that had not yet learned to be quiet. In those earliest ages, nothing was settled. The sun had only recently ignited into steady brilliance, and the planets were still gathering themselves, still sweeping their lanes, still colliding, still rearranging. Earth, too, was not the blue world we know. It was hotter, wilder, more like a glowing work in progress than a home. Its surface was unstable, its air thick with volcanic breath, its oceans not yet calm, its crust not yet firm enough to hold history for long. And then, in that restless time, something enormous happened. Something that may have been both violent and strangely creative. The leading idea scientists use to explain the moon's origin is often described as a giant impact. The phrase sounds sudden and harsh, like a hammer blow. But in space, even, catastrophes can unfold with an eerie kind of grace. A collision between worlds is not a sharp, ringing instant the way it would be on Earth. There is no air to crack with thunder. There is no ground to vibrate beneath your feet. There is only motion, mass, and heat, an event that would have been bright beyond imagining and silent beyond anything we can truly picture. A large body, sometimes imagined as roughly the size of Mars, crossed paths with the young Earth. Its orbit brought it close. Gravity tightened its grip, and then it struck. The impact would have melted and vaporized rock. Not just scattered debris, but a storm of incandescent material. Stone turned to spray, minerals turned to mist. Some of that matter fell back to Earth, adding to its mass, sinking into its depths. But a great deal of it was flung outward, forming a glowing ring, a swirling disk of molten fragments and vapor that circled the planet like a temporary halo. If you could have watched from a distance, far enough to survive, far enough to see, Earth would have looked like a lantern wrapped in a spinning veil. And within that veil, slowly, the moon began to gather. At first, it would not have been a single object. It would have been countless pieces, clumping and colliding, merging and breaking, then merging again. Gravity is patient. It does not need a plan. It simply pulls, and over time it turns scattered rubble into shape. Bit by bit, orbiting debris became a body. A rough sphere at first, uneven, glowing, still forming. And as it grew, it began to clear its neighborhood, collecting what it could, stabilizing, becoming more complete. In those early days, the moon would have been close, much closer to Earth than it is now. It may have hung huge in Earth's sky, filling it, dominating it, raising tides in molten rock and in the forming oceans. Earth and Moon would have been linked in a kind of gravitational conversation, each tug shaping the other, and while the Moon was forming, it was also cooling. This part of the story is softer, and it matters because it helps explain why the Moon looks the way it does today. Imagine the newborn Moon as a world of fire. Not the kind of fire that flickers, but the kind that flows. Many researchers think the Moon's surface may once have been a global ocean of magma, liquid rock spread across the entire sphere, glowing under the dark of space, slowly losing heat. As the Moon cooled, it began to separate itself internally, the way a thick soup separates when it sits. Heavy materials, rich in iron, tended to sink inward, gathering toward the center. Lighter minerals rose and floated. A crust began to form from minerals that could crystallize and buoy up, building a pale shell. Some of the Moon's ancient highlands may be made largely of these lighter minerals, like anorthosite, stone that formed early, long before most craters we see today. This early crust is one reason the Moon's surface has such contrast. Parts of it are extremely ancient, older than many landscapes on Earth, and in some cases older than any surviving Earth rocks at the surface. Earth, by comparison, constantly reworks itself. It has tectonic plates that slide and grind. It has oceans that erase shorelines. It has rain that crumbles mountains. It has living things that churn soil and build new layers. Even when Earth keeps memories, it tends to bury them. The Moon does not bury. The Moon displays. It has no thick atmosphere to soften impacts or to carry weather. No steady rain to smooth sharp edges. No rivers to carve and reshape. No forests to hide scars beneath green softness. Once a mark is made, it can remain for an almost unimaginable span of time. In a sense, the Moon is a place where the past can sit openly, like an old photograph left on a table. But even in those early ages, the Moon was not only cooling, it was moving, slowly drifting away from Earth. That gentle separation still continues today. Tidal forces, Earth pulling on the Moon pulling on Earth, transfer energy. Earth's rotation slows, almost imperceptibly, and the Moon's orbit expands. The Moon moves outward by a few centimeters per year, a tiny drifting that becomes enormous when you multiply it by billions of years. That drift changed the way the Moon appears to us. Over time, the Moon became tidally locked, meaning it began to rotate at the same rate it orbits Earth. One side always faces us. The same familiar face looks down through the centuries, so steady it can feel like a constant companion. And yet, even that face is shaped by deep history, by uneven crust, by early internal heat, by the lingering chemistry left from formation. The Moon is simple in some ways, but in others it is quietly complex. Its earliest era was not calm. It was molten and luminous, still settling into itself, still building a skeleton of stone. But as it cooled, it became more stable, more rigid. The interior lost much of its heat. Volcanism became less frequent. The Moon began its long career as a world that does not change quickly. That stillness is part of why it feels so serene to us. And it's also why the Moon can look scarred without looking wounded. The marks on its face do not bleed. They do not close. They do not heal. They simply remain, preserved by silence, held in place by the absence of wind and water. So when we gaze up, night after night, we are not seeing a smooth and perfect sphere. We are seeing the cooled surface of a world born in fire, hardened in time, and set into a quiet orbit like a thought that never leaves. And once the Moon had formed, once it had cooled enough to hold its shape, it entered the next great phase of its story, a phase that would carve its face into what we recognize today. Because after birth comes weather, not the weather of clouds and rain, the weather of space. Space is not empty in the way we sometimes imagine. It is a vast arena where objects move quickly and where the leftovers of creation still travel. Rocks, fragments, dust, wandering bodies caught in slow, looping paths. In the early solar system, there were more of these travelers than there are now. The planets were still cleaning their neighborhoods. The orbits of giant planets may have shifted, stirring up debris like a spoon stirring sediment in water. For the moon, this meant an age of impacts, an age of scars. When we look at the moon through a telescope, we see craters everywhere, overlapping circles, ridges, rims, shadows within shadows. The surface is so densely marked that it can seem like a texture rather than a landscape. But each crater is a story of motion. On Earth, most meteoroids burn up in the atmosphere, streaking into harmless light. Those that reach the ground are slowed, broken, softened by air. The moon has no thick atmosphere to offer that mercy. Out there, a stone from space does not whistle and flare and fragment. It simply arrives, fast, cold, and unstoppable. The speed is hard to hold in the mind. Many impacts occur at tens of kilometers per second. Faster than a rifle bullet, faster than a jet, faster than anything we experience in ordinary life. At those velocities, the impactor's size matters less than its energy. A relatively small object can create a crater far larger than itself, because the collision releases a blast that behaves like an explosion. And yet again, it is silent. A sudden conversion of motion into heat, into shock waves traveling through rock, into molten spray flung outward in long arcs. A crater is born in seconds, but the process is not gentle. The surface is crushed and excavated. Material is thrown out in a wide blanket of ejecta. The rim lifts. In larger craters, the center can rebound upward, forming a mountain-like peak, a stone splash frozen in place. If you could watch an impact in slow motion, if you could see the geometry of destruction, you might find it strangely beautiful, like a sculpture made by force. The moon is filled with these sculptures, created not by hands, but by gravity and speed. Some craters are crisp and young-looking, their rims sharp, their interiors cleanly defined. Others are worn down, not by wind or rain, but by countless smaller impacts over time, by the constant peppering of micrometeorites that slowly softens edges, blurs ridges, and turns rock into powder. That powder has a name, regolith. It is lunar soil, though it is not soil in the earthly sense. It holds no organic life. It is crushed rock, glassy fragments, tiny beads formed in impact heat, and dust so fine it can cling and drift like smoke when disturbed. It is a surface made not by erosion in water, but by abrasion in vacuum. The moon's regolith is one of the quiet achievements of time. It is the result of endless small collisions, each one too tiny to notice on its own, but together producing a soft blanket over hard stone. And then there are the rays. Some craters are surrounded by bright streaks that extend far across the surface. Thin lines, as if someone dragged a brush outward from the point of impact. These rays are made of fresh material excavated from beneath the surface, rock that hasn't been darkened by long exposure to the solar wind and micrometeorites. Over time, rays fade. They are like the moon's way of showing us which scars are newest. On the moon, new can still mean millions of years old. When we talk about a younger crater, we may be talking about an event that happened when early human ancestors were just beginning to walk upright, or long before that. The moon's timeline is so long that it makes our own history feel like a brief breath. But not all impacts were equal. Some were enormous, so immense that they reshaped entire regions. These are the basins, gigantic circular depressions, hundreds, even thousands, of kilometers wide. When an impact is that large, it doesn't simply punch a hole. It cracks the crust. It sends shock waves deep into the body. It rearranges the surface in a way that can still be seen from Earth as broad patterns of light and dark. Many of these basins are thought to have formed very early, during a time when impacts were far more common. There is a period often discussed in lunar science, sometimes called the Late Heavy Bombardment, an era when the inner solar system may have experienced a surge of collisions. The details are still debated, refined, argued, improved. Science does not sleep, it adjusts itself. But what remains clear is this: the moon's surface preserves evidence of an early epoch when impacts were frequent and powerful. On Earth, it is difficult to see this ancient bombardment because Earth's face is renewed and erased, but the moon has held onto it like a fossil. This is why the moon looks so battered. It is not because it was uniquely unlucky. It is because it is uniquely honest. It shows what the solar system was like long ago, when the planets were still settling into stability. Each crater, large or small, is also a kind of measuring tool. By counting craters in a region, scientists can estimate relative age. A surface with many craters is typically older because it has had more time to accumulate impacts. A smoother surface with fewer craters is often younger because something, like lava flows, resurfaced it later, wiping away older scars. So the moon's face is not just random pockmarks, it is layered time. It is a map of ancient events, written in circles. And there is another subtle detail. Many craters overlap. One impact makes a crater, then later another impact makes a crater that cuts into the first, interrupting its rim, partially covering it. In places, the surface becomes a palimpsest, a manuscript written over and over again, but never fully erased. The newer writing sits on top, while traces of the older remain. This is what it means for a world to have almost no erosion. It means the past is not lost, it is simply crowded. Even small impacts matter, because they create secondary craters. When a major impact happens, it throws out chunks of debris that can land far away, creating clusters of smaller craters. These secondaries can form chains, patterns, and sprays that decorate the surface like scattered seeds. Over immense spans of time, such events build complexity, little details that make the moon's surface feel richly textured when you look closely. And yet, from far away, when you see the moon as a simple disk in the night, the scars blend into a calm face. The damage becomes beauty. The complexity becomes a quiet pattern. It is one of the moon's strange gifts. It can carry the violence of its history without seeming aggressive. It can be marked by collisions and still look peaceful. Perhaps because nothing about it is active now in the way we recognize activity. There are no flames on the surface, no storms, no growing forests, no moving water, no creatures calling out into the night, only stone, dust, and sunlight. So when you stare up at that bright circle and notice its mottled skin, its darker patches, its pale highlands, its rings and ridges, you are looking at the record of countless encounters with wandering rock. You are looking at an ancient battlefield that has become a quiet monument. You are looking at the memory of the early solar system, preserved because the moon never learned how to forget. And as you let your eyes soften, as you let your breathing slow, you can imagine those impacts not as chaos, but as time's gentle chiseling. The universe shaping a face through long ages, leaving marks that do not fade. A silent world carved by motion. A bright companion holding its scars like stars hold their light, steadily, patiently, without hurry. And in that steadiness, something in us relaxes, because the moon does not demand anything from us. It simply remains. From far away, the moon looks like a calm face, pale and quiet, with soft shadows and familiar dark patches that make it seem almost expressive. Those dark patches have been noticed for as long as humans have watched the sky. They were once imagined as oceans, as great bodies of water held in the lunar bowl, reflecting some distant light. Early observers gave them names that still cling to them today: seas, bays, lakes, marshes. But when we drift closer, when imagination gives way to geology, we discover something even more haunting than water. Those dark regions are not wet, they are not liquid, they are the cooled remains of ancient fire. They are called Maria, Latin for seas, and the name remains not because it is accurate, but because it is poetic. From Earth, they look smooth and dark, like still water under a night sky. But up close, they are wide basalt plains formed by lava that once flowed across the moon's surface and then hardened into stone. To understand how these seas without water came to be, it helps to remember what happened before them. The moon's earlier surface was battered by impacts. Huge collisions carved enormous basins, circular depressions so large they could hold continents. These basins were, in a way, invitations. They were deep places, low places, places where gravity naturally gathered loose material. And they were also fractures in the moon's crust, wounds that reached down, cracking and weakening the surface. In the moon's younger days, its interior still held heat. Not the churning, restless heat of Earth, with its moving plates and constantly reshaping mantle, but enough warmth to keep portions of the moon's inside partly molten, capable of moving, capable of rising when pathways opened. After some of those giant basins formed, lava began to seep upward through cracks, spreading across the basin floors. Over time, flow after flow poured in, like slow black ink filling a shallow bowl. Each new flow covered older terrain, smoothing it, burying craters, and leaving behind a fresh basalt surface. Basalt is dark. It is rich in iron and magnesium compared to the lighter, older highland rocks. That difference in composition is one reason the Maria stand out so strongly against the brighter lunar highlands. The moon is, in a sense, showing us two different eras of its crust side by side: ancient pale highlands and younger dark basalt plains. When you look at the moon from Earth and see the dark sweep of Mare Imbrium, or Mare Tranquillitatis, or Mare Serenitatis, you are not seeing emptiness. You are seeing the frozen calm after volcanic motion. Lava once moved there, but it moved slowly, in silence, under a black sky. There's something almost soothing about that idea. A fire that does not roar, a flood that makes no sound, a world reshaped without storms. And if you could stand on one of those dark plains, if you could feel the ground beneath your boots, you might find it surprisingly flat in places, rolling gently, with low ridges and subtle wrinkles where cooling lava contracted and shifted. The Maria are smoother than the highlands, not perfectly smooth, but broad and simple in their shapes. They don't have the same rugged density of overlapping craters. They feel like resting places in the lunar landscape, wide and open. That smoothness is a clue to age. On the Moon, the older a surface is, the more craters it has. Time adds scars. So a region with fewer craters is often younger, meaning it formed after the most intense era of bombardment. Many maria are younger than the oldest highlands, though still immensely ancient by human standards, formed billions of years ago. The maria are not all the same age, and they didn't all form at once. The Moon's volcanic activity likely occurred in episodes, with lava rising at different times in different places. Some flows may have been relatively late in lunar history, long after the Moon had cooled substantially. But eventually, the Moon's internal heat diminished. Volcanism slowed, then mostly stopped. The basalt plains remained, dark, still, enduring. And this brings us to one of the Moon's most intriguing asymmetries, a detail that makes the Moon feel less like a simple sphere and more like a story with hidden pages. Most of the maria are on the near side, the side that faces Earth. The far side, the side we never see from the ground without spacecraft, is different. It is more rugged, more densely cratered, brighter overall, with far fewer expansive basalt plains. Why would the Moon have two faces that look so unlike each other? Part of the answer lies in the thickness of the crust. The Moon's far side crust, on average, is thicker than the near side crust. A thicker crust is like a stronger lid. It makes it harder for molten material underneath to break through to the surface. The near side, with thinner crust in key regions, may have offered easier pathways for lava to reach the surface and spread. Another part of the answer may involve chemistry. The Moon's interior is not perfectly uniform. Certain heat-producing elements, like uranium, thorium, and potassium, can be concentrated in certain regions. If more of these elements were present on the near side could have retained heat longer, sustaining volcanic activity, while the far side cooled and stiffened more quickly. These differences are subtle in the grand scale of the Moon's mass, but over billions of years, subtle differences become landscape. So the Moon's face is not just a surface, it is an expression of deep structure, of internal history, of the way heat moved and then faded. And all of this happened without the usual accompaniments of change that we know on Earth. No rain fell on those fresh lava plains to carve channels. No oceans rose to lap at their edges. No winds blew dust into dunes. No trees took root in cracks. The flows cooled, hardened, and then sat under the sun and stars, waiting. And waiting is one of the Moon's great talents, because the Moon is not a world of constant renewal. It is a world of preservation. On Earth, we often think of time as a force that erases. Time fades ink. Time wears stone. Time softens edges. Time turns sharp cliffs into gentle hills. Time breaks mountains down into sand and carries that sand away, grain by grain. But time on the Moon behaves differently. It does not erase in the same way. It accumulates. It layers. It quietly changes things, but without the drama of rivers and storms. The Moon is often described as airless, and in everyday terms, that's true. It has no thick, protective atmosphere like Earth. It has only an extremely thin exosphere, so tenuous it is closer to a whisper of atoms than a true blanket of air. And without a substantial atmosphere, the Moon cannot host weather in the way we understand weather. No clouds drift across its sky. No rain falls. No thunder rolls. There is no oxygen-rich wind to rust metal. No gentle breeze to carry scents. No pressure to muffle temperature swings. Because of that, the moon's surface experiences extremes. In sunlight, the ground can become intensely hot. In shadow, it can become bitterly cold. And the shifts can happen quickly as the long lunar day slowly moves. A lunar day, one full rotation relative to the sun, lasts about a month. That means sunlight can bake a region for many Earth days, then darkness can freeze it for many days more. This temperature cycling can stress rocks. On Earth, rocks crack partly because water gets into tiny fractures, freezes, expands, and pries them apart. On the Moon, there is almost no water to do that, but thermal expansion and contraction can still play a role. Rock heated under long sunlight expands. Cooled under long night, it contracts. Over time, this can contribute to fracturing. Slow, patient, microscopic change. But the Moon's most important shaping force isn't wind or water or ice. It is space itself. The Moon is constantly exposed to what we can call space weathering, a steady, invisible storm of particles and impacts that, over time, transforms the surface. One part of this is the solar wind, a stream of charged particles flowing outward from the sun. Without a strong global magnetic field and without a thick atmosphere, the Moon's surface is directly bombarded by these particles. Over vast time, this bombardment can alter the chemistry of surface grains, darken them, and change how they reflect light. Another part is cosmic radiation, high-energy particles from beyond the solar system that can strike the surface, interacting with atoms, occasionally producing new isotopes. It's subtle, but it's part of the Moon's quiet conversation with the universe. And then there are micrometeorites, tiny grains of dust and small fragments traveling through space. They strike the Moon constantly. Most are too small to make dramatic craters visible from Earth, but collectively, they do something profound. They grind the surface down, turning solid rock into regolith. Regolith is the Moon's soil, though it contains no organic life. It is a layer of crushed rock and dust that can be several meters thick in many places, deeper in some. It holds within it tiny glass beads formed when micrometeorites flash melt the surface and then cool instantly in vacuum. It holds sharp-edged grains that have not been rounded by water. On Earth, sand grains tumble in rivers and waves, becoming smoother over time. On the Moon, grains remain jagged, fractured, harsh. This regolith is one reason astronauts described the lunar dust as clingy and stubborn. It can stick to surfaces, and because it is sharp, it can be abrasive. But beyond those practical details, regolith is a symbol of time. It is rock made into powder by countless impacts. If you could scoop a handful of lunar regolith, you would be holding billions of years of slow violence turned into fine dust. And yet, from another perspective, that dust is also a blanket. It lies over the Moon's surface like a quiet covering. It softens the look of the landscape from a distance. It fills small depressions. It hides tiny features. It is the Moon's version of weathering. Not smoothing through flowing water, but smoothing through countless little collisions. Still, even that kind of weathering is not like Earth's. It does not carry material away in rivers. It does not deposit layers in deltas. It mostly stays where it is, being churned and mixed by further impacts. This mixing is called gardening, impact gardening. It's as if the moon's surface is being gently stirred over time. New material is brought up. Older material is buried. Layers are mixed. It's slow and constant, and it changes the very top layers of the moon in a way that is almost alive in its persistence. But what about the scars? Why do craters remain so sharply defined? Because there is no efficient eraser. On Earth, erosion is relentless. Water flows downhill. It seeks cracks. It dissolves minerals. It carries grains away. Wind pushes sand against stone like a file. Glaciers scrape valleys. Plants wedge roots into fractures. Animals burrow and churn. The atmosphere itself participates in a chemical dialogue with rock, oxidizing and breaking down materials. On the moon, most of those processes are absent or extremely limited, so a crater formed billions of years ago can still be visible today. Its rim may be softened by micrometeorite bombardment, its interior slowly filled by regolith, but its outline often remains. Ancient basins still show rings. Old lava plains still reveal subtle wrinkles. The moon is a place where geometry can survive. This is why the moon is so valuable to scientists. It is a record keeper. It holds evidence of impacts that would have been erased on Earth. It preserves a timeline of solar system events, like a stone archive, and in some places, the moon preserves secrets, even more carefully. Consider the polar regions. At the moon's poles, the sun hangs low in the sky. Some crater floors are so deep and so positioned that sunlight never reaches them. These are permanently shadowed regions. They are among the coldest places in the solar system, cold enough that water ice delivered by comets or created by chemical reactions can survive for extremely long periods. In those shadows, the moon is not only preserving scars, it may be preserving molecules. Hidden ice in the darkness feels almost like a metaphor, a quiet reserve of something life needs, stored in the cold, untouched by sunlight. And then there's the soundless quality of it all. On Earth, we associate movement with sound. Wind moans, rain taps, waves crash, trees rustle. Even distant thunder reminds us the atmosphere is alive with motion. On the moon, even an impact would not sound like anything unless you were in contact with the ground, feeling vibrations through your body. Sound needs a medium: air, water, solid contact. In vacuum, there is no air to carry it. The moon is not only visually still, it is acoustically empty. That silence is one reason the moon can feel so peaceful in our minds. Even when we know its history is violent, we also know that violence has passed. The present is quiet, the scars are old, the surface is stable. Yet the moon is not completely inert. It does experience small moonquakes. Its crust can shift. Temperature changes can cause rocks to crack. Tiny impacts still occur. The solar wind still blows. But compared to Earth, it is a world of gentle change. A world where the greatest sculptor is time, working through the smallest tools. And when you combine all of this, the dark basalt seas formed by ancient lava, the bright highlands formed in the moon's earliest cooling, the crater scars preserved by a lack of erosion, you begin to see why the moon's face looks both scarred and calm. It isn't a contradiction, it's a signature. The moon is a place where the past is visible and the present is silent. A place where ancient fire became stone, where collisions became rings and rays, where dust became a blanket, and where the night sky holds a companion that does not speak but never forgets. As you listen, as you breathe, you can imagine that moon above you, not as an object that simply hangs there, but as a patient archive, turning slowly in space, keeping a record that Earth cannot keep for long. A scarred face, not because it is broken, but because it remembers. And even now, after all those ancient collisions, after the lava seas cooled into dark stone, after the dust settled into its soft, powdery blanket, the moon still holds more history than it shows at first glance. Because what we see from Earth is only one side of its story. The moon keeps a secret face. For most of human history, the far side was pure imagination. We could guess, we could wonder, we could argue about what might be there. But we could never truly know, because the moon turns in a way that keeps the same hemisphere facing us. It's as if the moon decided, very early on, to become a companion with a single expression. Steady, familiar, always the same. But when we finally learned to look beyond that familiar face, the far side revealed itself as something different, almost like a cousin rather than a twin. The far side is brighter overall, more rugged and more densely cratered. It feels older, not because it formed earlier, but because it was resurfaced less. There are fewer broad, dark basalt plains, fewer of those seas that make the near side feel smooth and patterned from a distance. Instead, the far side looks like a world that stayed closer to its first crust, an ancient shell that never received the same wide blankets of lava. If the near side is the moon's calm mask, the far side is the moon's raw memory. And within that memory is one of the most profound features on the entire moon. A gigantic impact basin so vast it's hard to grasp without a map. The South Pole Aitken Basin. It stretches across much of the far side near the lunar South Pole. A scar so old and so immense that it feels less like a crater and more like a reshaping of the moon itself. Basins like this are not just holes. They are deep rearrangements. They excavate material from far below the surface, sometimes exposing rocks from layers that would otherwise remain hidden forever. In that way, the far side is not simply the other side. It is a window into depths, into older crust, into buried structures, into the moon's internal story. And this is part of the moon's hidden history today. The idea that the surface is not merely a face, but a thin skin. Beneath it lies a body with layers, with composition, with subtle motion, slow, quiet motion that never quite stops. The moon looks still, but it is not perfectly still. It has a kind of lingering life, not the life of forests and oceans, not the life of breathing things, but the slow life of a cooling world, a body settling into itself over billions of years. One of the gentlest hints of that lingering life is the phenomenon we call moonquakes. The word quake can make us think of sudden destruction, cracked roads, collapsing buildings, rolling waves. But on the moon, quakes are different. There is no ocean to turn avoiding into catastrophe. There are no cities to shake. A moonquake is simply the moon flexing, releasing tension, shifting in the quiet. Some moonquakes are caused by tides, not water tides, but tidal forces in rock. Earth's gravity pulls on the moon, stretching it slightly. The moon pulls back. This gravitational embrace is constant, and though the movement is small, it is persistent. Over time, that steady pull can build stress in the crust, and stress eventually becomes release. Some moonquakes come from temperature changes. The lunar day is long. Sunlight lingers for many Earth days, heating rock slowly, deeply. Then, darkness returns for many days, cooling it again. Expansion and contraction, over and over, can produce cracking and settling, especially near the surface. It's a quiet kind of change, like a doorframe adjusting in winter cold, only on a planetary scale. And some quakes occur deeper, far below the regolith and the crater rims, in places where rock still carries memory of internal warmth and ancient structure. These deeper quakes can be surprisingly persistent. On Earth, an earthquake can roar through in seconds or minutes. On the Moon, because the interior is different, drier, more rigid, less fractured by water, the vibrations can ring longer. The Moon can ring like a bell, not loudly, not in air, but as a slow trembling in stone. It is a strange thought, a silent world that can still vibrate, a world that can still respond, a world that is quiet but not numb. And if the Moon can quake, it suggests something else as well. That the Moon has internal layers that still matter, a crust, a mantle, a core, a structure shaped by early differentiation, heavy elements sinking, lighter elements rising, and shaped again and again by impacts so massive they may have stirred the interior in ways we avoiding fully understand. Even today, the Moon's internal story is studied through careful measurement. Tiny changes in motion, subtle wobbles, the way spacecraft orbiting the Moon speed up and slow down as gravity varies. The Moon's gravity is not perfectly uniform. Some regions are heavier than others. There are places where mass is concentrated below the surface, remnants of ancient basins that were later filled by dense volcanic rock, leaving gravitational fingerprints. These invisible fingerprints guide orbits, tugging gently on passing spacecraft, like underwater currents tug on a drifting leaf. So, there is a hidden moon beneath the visible moon, a moon of mass and structure, of density patterns, of slow interior cooling. And then there is another kind of mystery, one that looks almost delicate compared to basins and quakes, yet is no less haunting. If you look at detailed images of the lunar surface, you can find strange, pale, swirling patterns, soft, curving ribbons that seem almost painted across the ground. They don't follow crater rims the way you might expect. They don't look like lava flows. They look like something lighter brushed over darker stone, as if a gentle hand traced loops and curls in dust. These are lunar swirls. They are among the Moon's most subtle oddities, because they seem more like a pattern than a landscape feature. They can be bright compared to the surrounding ground, and they often appear in places associated with unusual magnetic fields, localized magnetic anomalies. The Moon does not have a strong global magnetic field like Earth, but in certain patches, the crust holds magnetized remnants, like fossilized hints of an earlier magnetic past, or of impacts that altered magnetic minerals. One idea is that these magnetic patches can partially shield the surface from the solar wind. And if the solar wind contributes to darkening lunar soil over time, then a sheltered area might stay brighter longer, preserving a lighter tone while surroundings gradually darken. In that way, the swirls may be a visible record of invisible protection, a gentle boundary where space weathering is altered, slowed, reshaped. It's the kind of phenomenon the Moon seems to enjoy, quiet, patient, almost minimal, yet rich with implication. The Moon is full of these soft riddles, not loud mysteries, but subtle ones. And then, at the poles, where sunlight moves differently, where the sun skims low and shadows can become permanent, the Moon holds perhaps its most practical secret. There are places on the Moon that never see sunlight. Craters near the poles can have floors that remain in darkness for unimaginably long time. In those cold traps, temperatures can drop so low that water molecules, delivered by comets, by meteorites, or produced by chemical interactions over time, can settle and stay, not as flowing water, not as glistening lakes, but as ice mixed into dust, grains, and shadowed ground, a reserve held in stillness. It's a strange pairing, the moon, so famous for its dryness and airlessness, possibly storing water in the places where light never arrives. This ice matters in more than one way. It matters scientifically because it could contain a record, a chemical fingerprint of how water moved through the inner solar system. Ice can trap atoms and molecules, preserving them like a tiny archive. It matters practically because water can be split into oxygen and hydrogen, air and fuel, and because any long-term human presence beyond Earth benefits from resources found locally. But even if we ignore future plans and simply imagine the moon as it is, right now, the idea of ice in permanent shadow adds a quiet richness to the lunar character. It means the moon is not only a surface of scars and stone, it is also a world of corners, places where sunlight never touches, where time keeps its cold treasures untouched. And all over the moon, there are features that remind us the surface is not the whole story. There are long, winding rills, channels carved not by water, but by lava long ago, or by collapsing roofs over ancient lava tubes. There are cliffs, scarps, and subtle ridges where the crust has shifted. There are pits that open into darkness, entrances to hollow spaces that might stretch underground. There are bright, fresh craters with rays like spilled chalk, and older, softened craters whose rims have been rounded by the endless whisper of micrometeorites. There are also places where the moon seems to have shrunk slightly over time as it cooled, producing wrinkles in the crust, like a cooling apple skin pulling tight. These are not dramatic folds like mountain ranges on Earth, but small compressive features, quiet proof that the moon has been contracting, settling, tightening its stone skin. So the moon's hidden history today is not only about what happened long ago, it's about what is still happening slowly, cooling, cracking, flexing, holding. And of course, the moon's most intimate layer of hidden history is the one we brought back with us, the rocks. When humans and robotic missions collected lunar samples, they did more than gather stones. They gathered time, because a lunar rock is not just a rock. It can contain records of impacts, of heating, of cooling, of exposure to cosmic rays. It can carry isotopic signatures that help reveal age and origin. It can be a piece of highland crust that formed early, or a basalt from an ancient lava plain, or breccia, a rock made of broken fragments fused together by an impact, like a mosaic created by violence. On Earth, rocks are often altered. Water seeps through them. Chemistry changes them. Life burrows and breaks them down. But many lunar samples remain closer to their original states, preserving ancient conditions. That's why scientists study them with such care. They aren't just souvenirs, they're messages. And beyond our samples, the moon continues to be mapped and measured from orbit, each pass adding detail, each dataset sharpening our picture. We now see the moon not as a smooth lamp in the sky, but as a complicated world with regional differences, with hidden basins, with anomalies that still challenge simple explanations. We've learned that the moon's far side is an ideal place for certain kinds of listening, because it is shielded from Earth's radio noise, a natural quiet zone. We've learned that some of the most valuable real estate on the moon might not be the dramatic equatorial plains, but the polar regions where sunlight and shadow create stable patterns. Places where you can find long-lasting light on some ridges and deep cold in some craters, all within manageable distances. We've learned that silent does not mean empty, and yet, with all we've learned, the moon retains its most powerful quality, its stillness. Even the idea of future outposts, future instruments, future footprints, these possibilities do not disturb the moon's emotional presence, because the moon absorbs change slowly. The marks we leave may last, yes, but the moon's overall character remains the same: wide, pale, quiet. There is something comforting about a world that does not constantly reinvent itself. On Earth, change is everywhere. Seasons turn, weather shifts, cities rise and fall, coastlines move, forests burn and return, life grows, decays, and grows again. Earth is alive with motion. The moon offers another kind of reality, continuity, a face that remains, a landscape that remembers, a place where the past can be seen, not imagined. And perhaps that is why even now the moon continues to pull at us, not only with gravity, but with a kind of calm. It is a companion that doesn't speak, and yet it tells a story simply by existing. It tells us that time can be vast, that violence can become stillness, that heat can become stone, that a world can be scarred and yet serene. So when you look up at the moon, whether it is a thin crescent or a full shining disk, you can imagine the hidden history layered beneath that light. The far side, rough and ancient, holding giant basins and thicker crust. The interior, slowly cooling, occasionally trembling in moonquakes. The swirls, pale and looping, where magnetism and solar wind leave gentle signatures. The poles, where shadow stores cold and perhaps ice, waiting in darkness. And the surface itself, everywhere covered in dust that was once rock. Everywhere marked by impacts that happened before any human name existed. Everywhere quiet under the constant soft fall of sunlight. A world that seems silent, not because it has nothing to say, but because it speaks in patience. And in that patience, it becomes an easy thing to rest beneath. A light in the sky that does not hurry. A companion that keeps its scars like a map of deep time. And a reminder, as you drift towards sleep, that even the quietest places can be full of story.